So last time we were trying to prove, that this is isomorphic to Z. Fundamental group of the circle is isomorphic to Z, and along the way we needed a fact, so we use two facts to prove this. And the first one was this: for each path f from an interval to circle starting at a point x0. What I mean starting at a point, so the point 0, the end point 0 of the interval is mapped to x0. There is a unique lift, f tilde starting at any x0 tilde which lies above x0. So here is the situation. I have the interval 0, 1, and this is mapped to the circle, so that 0 is mapped to f of, 0 is mapped to x0. And suppose that, so I have this projection covering space. Remember that this is given by Bs, let's say cosine 2 pi s sine 2 pi s, so that every integer is mapped to 1, not necessarily x0. x0 can be any point, but suppose x0 tilde is a point, so that p of x0 tilde is just x0. Then the conclusion is that there is a unique lift. Okay, there is a unique lift f tilde, so that f tilde is a lift, meaning that this composition is equal to f, and f0 tilde, f tilde at 0 is equal to x0 tilde. Okay. Now, last time we proved the existence part of this. We proved that such f tilde exists. So last time we have proved that such f tilde exists. Now, today we will prove that it is unique. So now we will prove that f tilde is unique. Now let's see how we can do this. Okay. So uniqueness part. Let F1 tilde and F2 tilde be two lifts of F so that both F1 tilde at x0 at 0 and F2 tilde at 0 are equal to x0 tilde. So we must prove this F1 tilde is the same as F2 tilde. Okay. Now how we can do this? Okay, so let A to be the following set. S in I, the interval 0, 1, so that F1 tilde S is equal to F2 tilde S. So the set of points where F1 tilde and F2 tilde are equal to each other. We just need to show that this A, subset A, is equal to the domain of our function, which is just the interval 0, 1. Note that this set is not empty. Note that F1 tilde at 0 is equal to F2 tilde at 0. Therefore, 0 is in this A, so that A is not empty. Well, in this case, I guess it will be equivalent. We will show that A is equal to the whole interval, and this is the domain of our function. So it will be both closed and open. Okay. Well, A, we will show that A is both open and closed, and since A is not empty and the interval I is connected, that will imply that A is equal to I. Since I, which is the interval 0, 1, is connected, it suffices to show that A is both open and closed. Okay. Değil mi? Connected bir setin boş olmayan open ve close bir seti varsa o set kendisine eşit olmak zorunda. Dolayısıyla bunu yapmak yeterli. Closed kısmı kolay. Çünkü A is closed since F1 tilde and F2 tilde are both continuous. Yani şöyle diyelim, the interval 0, 1 has this standard topology, and that topology closed sets are characterized by sequences, right? A set is closed if and only if every convergent sequence in that set has its limit in that set. So if this is the case, then it will be called closed. And here, if let's say Sn is in A and limit Sn is, let's say, is equal to x0 exists, then of course we have f tilde Sn is equal to f1 tilde is equal to f2 tilde Sn for all n. But since f1 and f2 are both continuous, I can just take the limit. So taking limit, so f1 tilde s0, which is just limit as n goes to infinity f1 tilde Sn, but that is equal to the limit of f2 tilde Sn. And since f2 is continuous, this is just f2 tilde s0, meaning that s0 is in also A, because f1 tilde is equal to f2 tilde. So if Sn's are in A, and if Sn has a limit, then the limit point also lies in A. Therefore, A is closed. Hence, A is closed. A, evet. Olur. Orada şöyle bir şey var tabii işte. R'ye gittikleri için onu yapabiliriz. Tamam. Evet, yani herhangi bir covering space için çalışmaz o da. Çünkü hani o kümede toplama çıkarma var mı? Ama burada gerçi burada biz herhangi bir covering space aldık değil mi? R mi aldık? R aldık. Tamam. R aldıysak sorun yok. Tamam. Yani şöyle bir setup olsaydı liftler var. Hani burada toplama işlemi bile olmayabilir. O zaman da hani o argüman çalışmaz ama bu argüman çalışır. Ama bu örnekte, bu şeyde haklısın. Onu yapabiliriz. Öyle mi? Ha. Bunu aslında şey diye mi yapıyoruz? Ben de sanki aklımda öyle kalmıştı ama bir şekilde arada. Evet, tamam. Şöyle f i'dan x'e, değil mi? Yok, burası y, şurası x, değil mi? Tamam. Şöyle f tilde var. Tamam. Ya ispat aslında R'de ne yapıyorsanız R ile Esman'da aynısı da işte ama haklısın, hani R durumunda senin dediğinde yapabiliriz. Peki open olduğunu nasıl söyleriz? How do you say it's open? So A is open. Well, we can do it as follows. Let's say x0 is in A. Okay. Then what do we know? F1 tilde x0 is equal to F2 tilde S0. And ya da şuna S0, neyse tamam böyle olsun. And so we have the following picture. There is some S0 here. and there is some f here. This is my space y, and so I have f of s0, and here we have two functions, f1 tilde and f2 tilde, two functions, and in x they agree at a point. So something like this, one has such a graph, the other one has such a graph, and at this point they agree. So this is the point f1 tilde s0 is equal to f2 tilde s0. We would like to show that actually something like this cannot occur. Okay, how we can do this? Well, you see, since this is a covering space, there is an open set here, U, so that the inverse image of this open set is a disjoint union of open sets in X, each of which is homeomorphic to U. One of those open sets will contain this point, of course. So there is some open set here, V, and this V is homeomorphic to U. So this is a homeomorphism, right? The inverse image of this is a disjoint union of open sets. Each of them is homeomorphic to this one. And one of them will contain this point. And then we do what? Well, via this projection function, the picture over here and the picture over here should be the same. Both of these functions, f1 tilde and f2 tilde, projects to f, but so note that, so p from v to u is a homeomorphism, and what I know is the following. So since this is an open set, inverse image of this open set under this continuous function is an open set in the interval I, and that so is an open set in I, and that open set contains S0. Therefore, I can pick up an interval like this, so that that interval is mapped to inside U. So this is mapped to inside U. Okay, this interval. And then this interval, of course, is mapped to where? Okay. V. Yes, inverse image of this, of course. Şimdi şunu biliyoruz. So let me write down what we have. So let me say this interval J. Okay, this is an interval J. It's mapped here, and this J, since it is connected, its image is connected, right? So this is a connected set. Connected. I can pick an interval. It's connected. Therefore, the image of this J will be connected. And I know that inverse image of U is a disjoint union of subsets. Therefore, the image of J should lie in exactly one of these open sets, because inverse image of this are disjoint copies. Therefore, this should be contained in exactly one of these subsets V. And I know that this point is already contained in this open set. Therefore, the image of this whole J lies inside V. Yani şu interval'ın imajı bu U şurada, bu U'nun inverse imajı U'nun kopyalarından oluşuyor. Bu U connected olmayabilir. Öyle bir şey assume etmiyorum ama şunu biliyorum. Şunların her birisi buna homeomorfikler. Ve elimde şurada J var. J connected. Connected olduğu için bunun imajı bir kısmı burada, bir kısmı burada olamaz. Bunun hepsi bir tane bu setlerden birinin içinde olacak. Ama şunu biliyorum. Bir nokta zaten şunun içinde, bu V'nin içinde. O zaman bunun tamamı bu V'nin içinde olacak. Tamam mı? Yani şunu diyebilirim. Is a homeomorphism. Okay, now if J is an interval around S0 so that f of J lies inside U, then F1 tilde of J and F2 tilde of J should lie in exactly one of the disjoint open subsets U alphas diyelim, so that P inverse of V is the disjoint of sets of U alphas and P from each U alpha to V is a homeomorphism. Yani pardon, karıştırdım. U'la V'leri karıştırdık. Buradaki set U'ydu. Şu U'nun ters görüntüsü V alfalardan oluşsun. Özür dilerim. V alfa. Okay. Şurada nasıl gözüküyor? Videolarda kötü gözüküyor da bu. Bugün iyi gözüküyor. Okay. Şunu kapatayım ama. Okay, so this so image of J is contained in one of the V alphas. Let's call that V alpha, the one which contains the image of J under F1 tilde and F2 tilde to be V. So we have this picture. We have this V here and U here. Now what we have the following. I have this interval containing this point, and then I have F. Its image is inside U. Okay, U. And I have F1 tilde and F2 tilde, two maps. Their image lies inside V. And here I have a homeomorphism. Now this is a homeomorphism. And we have this commutative diagram. So F1 tilde composition P is equal to F, and this is P composition F2 tilde. But you see, since P is a homeomorphism, I can just apply the inverse map of this, right? So I have this P inverse, this locally homeomorphism. Applying that, we see that F1 tilde is equal to, so S is equal to F2 tilde S for all S in J. So what we have seen is then, if these two lifts agree at a point S0, then I can find an open interval on which these two lifts also agree. Therefore, the set A is open. So this implies that A is open. And this finishes the proof because A is both open and closed. Therefore, this implies A is equal to the whole interval. Therefore, F1 and F2 are the same. Onu söylemiş miydim? Ha, evet. Şurada söylemiştik. Tamam. Anlaşıldı mı? Efendim? Evet, evet, evet. Bütün esprisi o zaten. Covering space, local olarak homeomorfizm ama objeleriniz globally tamamen farklılar. Tamam mı? Ya mesela işte yapmıştık, hani şöyle bir surface alın. Bunun şöyle bir covering space'i var. Yani bir tane map var, local homeomorphism. Bunun 3 tane deliği var, bunun 2 tane var. Ama hani local homeomorphism olduğu için buradaki bir adam alın, bunun burada bir pre-image'ini alın. Bu hareket ettikçe bu da işte bu homeomorfizmle hareket etsin, local homeomorfizmle. İkisi de aynı yerde olduklarını düşünürler. Hani dünyalarının farklı olduğunu bile fark etmezler. Bütün uzayı göremiyorlarsa. Hı. Evet, evet, evet. Evet, yani tabii ki bu aslında şeyi söylüyor, yani bu resim değil mi, şey olamaz, hani bu local homeomorphism ise biri böyleyse biri böyle olamaz. Yani işte o laflarımız yok burada, hani e, e, ama hani işte o dediğin şeyi hani uygun şekilde söylemek için burada işte compact connectedness vesaire öyle biraz cambazlık yapmak gerekiyor. Ama işte burada continuous kategoride çalıştığımız için hani tangent, onların hiçbirisi yok. Evet, evet, evet, evet, evet, evet, evet. Okay. Yani covering space iki uzay arasında bir fonksiyon, örten bir fonksiyon ama lokal olarak homeomorfizm. Ya aslında ondan biraz daha fazla işte şey diyoruz, hani disjoint union of open setler var vesaire diye. Hani local homeomorfizmden biraz daha fazlası aslında. Şimdi evet, bu bitti. Ha, şimdi bir de petleri lift ettik. This A was lifting of pets, B was lifting of homotopies. So proof of B. Let me write down the statement of B first. So statement was this: let F this time be a homotopy, and F tilde from any interval to X be a lift of the function f of s defined by this. So this is one edge of the homotopy. Yani bir tane fonksiyon tanımlıyorum. Bu homotopinin sıfırdaki hali. Bu da bunun lifti olsun. Bir ucun. O zaman iddiamız şu. Then there is a unique lift f tilde of f so that f tilde s0 is the lift of f. Yani şunu söylüyoruz. So what we're claiming is this. This time I have my I cross I, okay? This is the S direction. This is the T direction. And we have a function, homotopy to Y, okay? And I have the following. X. So, and we have F tilde. F tilde is what? F is this edge of the homotopy. So F of S is big S0, okay? So on this edge, my function, my homotopy is little f, and this f tilde is the lift of this gadget. So it is the lift defined only on this edge. The statement is that then there is a unique lift f tilde defined on this whole rectangle, and it extends this little f tilde. Yani şunu söylüyoruz. Elimde bu homotopi varsa, diyelim ki onu şöyle çizeyim. Şöyle bir şey. Tamam mı? Şurası işte f'in görüntüsü. Eğer bunun lifti varsa, şöyle diyeyim, bu f tilde, o zaman bütün bu homotopinin de lifti var. Bunu da uniquely extend edebilirim. Bu f tilde olmak üzere. Şeydekinin aynısı aslında. Homotopinin başlangıç noktasını siz bir şekilde yukarı kaldırırsanız geri kalanı otomatik olarak kalkıyor. Petlerde de öyleydi. Uç noktanın bir liftini söylerseniz geri kalanı otomatikman kalkıyor. Burada da homotopinin t eşittir 0 anının liftini verirseniz geri kalanı otomatikman kalkıyor. Tamam mı? Onu söylüyor. İkisi de o anlamda hani bir yerde analog statement'lar. Hani homotopinin PET'i de bir homotopi gibi görebilirim. Hani PET'in kendisini de. Başlangıç noktasının liftini verirseniz bütün fonksiyonun unique bir liftini buluyorsunuz. Nasıl? Hı. Evet, şöyle. Yani tabii bunun lifti F tilde ama G tilde bize verilmiş değil. Verilmiş değil. O şeyden otomatikman gelecek. Ben eğer böyle bir homotopim varsa F tilde'nin liftini verirsem bunun lifti otomatikman geliyor. Bunun lifti üzerinde kontrolüm yok ama. Yani şöyle bir G tilde diye bir şey elde ediyorum burada. Petlerdeki durum da aynı. Hani bir tane diyelim ki bir petim var. Şöyle ben şu noktanın, şimdi bu noktanın bir sürü burada lifti olabilir. Hangisini verirsem unique bir lift veriyor. Onun uç noktası uniquely determine ediliyor. Buradan başlasın deseydim şöyle gelecekti. Başka bir muhtemelen uç nokta olacaktı. Buradan başlasın deseydim başka bir tane elde edecektim. Başlangıç noktasını seçtiğiniz anda fonksiyonun tamamı unique bir şekilde belirleniyor. Yani çünkü şey düşünün. Siz buradasınız, aşağıda yürüyorsunuz. So suppose that you are here and you just walk here, and then there is a homeomorphism. There is a guy here just above you and he just follows you. So what you do, whatever you do, he does the same thing. Therefore, there is a unique lift. But there might be another guy here and he also follows you. So this guy will give you another lift, okay? Because there is a homeomorphism. So this, both of you see the same picture. Yeah. Uh-huh. Uh-huh. No, but okay. So I claim that this F tilde is unique, but once you specify the lift of this gadget, so I say that the lift of this, my homotopy restricted to this edge is a function. Once I specify the lift of this function, then there is a unique homotopy. If I specify another lift for this F, suppose not this one, but something like this, then I get another homotopy, lift of the homotopy. This picture is analogous to what we have seen for paths. Once you specify the lift of initial point, then the rest is automatic, okay? Okay. Okay, now let me, so this is my covering space, and I have my homotopy, and our aim is to find F tilde okay. Of course, F tilde just satisfies these conditions. It's a lift, meaning that P composition F tilde is equal to F, but it satisfies so-called this initial condition. Değil mi? Bunu initial condition gibi görebiliriz yani. Evet evet, bu haklısın. Şu da. Yok, bu X'e. Tamam. Tamam. Özür dilerim. Hı hı. Tamam. This is to Y. Yes. Okay, how do we do this? Existence part, so we claim that there is a unique lift. Existence part comes from existence part of A. How? Okay. Now let's explain this. For any fixed S0, consider the path. Consider the path F S0 T. Here T is the variable. So what I'm doing is this. For any S0 here, I look at this interval and its image under F. So what it gives me, it will give me a path like this. And I have, so F restricted to this edge is called F, and F has a lift, right? This is given. Therefore, I have a path here, and this end point of this path, which is the image of this point, is lifted to some point here. But once I am given a lift of this point, so what is this point? This point is F of S0. What is this point? This is F0, F tilde S0. And P composition this, so P composition P of F tilde S0 is just F of S0, F of S0, right? So I am given a lift of this point. Now the existence part of path lifting gives me what? If I have a path and a lift of initial point is given, then there is a unique lift of this path. Right? There's a unique lift of this path. Buna isterseniz ben ne diyeyim? Yani şuna, buraya gamma derseniz, yani bu gamma, bu gamma'nın unique bir tane lifti var, gamma tilde. Okay. And I define my F tilde as T. So suppose this is my T. How do I define this? Gamma, but you see this gamma depends on the point S0. So let me just call it gamma S0. Anyway, for each S0, I have a different gamma. This is its unique lift. So I can just define this as follows. This is just gamma S at T. Okay. So I can just define my F tilde like this. And I know that the image of this guy under P, so this thing under, this is just P of gamma, this is tilde, of course, tilde S T, but this is just gamma tilde is the lift of gamma, therefore this is just gamma S T. Gamma S T is just, of course, this is just FST, değil mi? Because for any S0, I look at this path, this interval, I look at its image under F, I call it gamma S, and then it is a unique lift, and then I use this lift to define F tilde. Tamam mı? Ve zaten bu bunun lifti olduğu için buna P uygularsam da bunu geri alıyorum. Dolayısıyla F tilde'ye P uygularsam F'i bulacağım. So such an F tilde exists. Uniqueness comes from this. Not uniqueness. This is existence. Okay. Evet, 3 dakikam kalmış. Şey söyleyebilir miyim? Evet, onu da söyleyebilirim belki. 2-3 dakikada. Uniqueness kısmı da basit. Dönmedi. Okay. Uniqueness of F tilde comes from uniqueness of part of A, because the restriction of F tilde to each vertical line segment, yani işte oraya çizdim, S0 cross I is the unique lift of F S0 T starting at F tilde S0. Yani bu for the existence I used this lift, but for the uniqueness I can use it again. Okay. So what is left? Are we done? No, unfortunately. You know, the way we defined our function, so this thing is defined how? It is defined as gamma tilde S at the point T. So for each S here, I look at this point, this line segment, it gives me a path in Y, and then this point, so gamma S0 has a lift here, and therefore this path has a unique lift, and then at any point here, T, so this point is ST, that point was lift here, so mapped here under F. Now I just look at the corresponding point here. So this is just gamma s tilde t. And this is how I define my function. Aslında choice yok da. Yani şey var. Şimdi s verildiği zaman böyle bir fonksiyon var. O fonksiyon buradaki değerine bakıyorum. All of these paths are continuous, but it doesn't guarantee that this function is continuous. So we must show this f tilde is continuous. Okay? Bunu yapmamız lazım. Yani we know that f tilde is continuous on each line. On each vertical line, it is continuous because it is the continuous lift of a continuous function. But it doesn't mean that this f tilde is continuous. Tamam mı? Onu yapmamız gerekecek. So, and that's not easy. Okay, so that's the difficult part actually. But we will do it next time. Yani çok da zor değil de bir compactness argümanı var orada. Kolaylıkla atlanabilecek bir şey o. Hani insan bakınca ya bu continuous der de değil yani. Okey. Sorusu olan var mı arkadaşlar? Yok, o zaman kapatayım.